y double prime minus 7y prime plus 10y equals 24 e to the x, where y1 is e to the 2x. So we're gonna let y equals the u as a function times y1, which is u times e to the 2x. So this one is the general solution. Okay, and then the next step, we're gonna have to find y prime and y double prime. Since we claim this is a solution, so it has to satisfy the differential equation provided. Okay, so y prime using the product rule, because we treat u as another form of the function, so just the product rule. So u times 2 times e to the 2x plus u prime times 2 e to the 2x, and then keep going. So 4 u e to the 2x plus 2 times, no, 2u, sorry. Hang on. 2u prime e to the 2x. And then the second term, the same kind of derivative. We have 2u prime e to the 2x plus u double prime e to the 2x. And then collect like terms. We have 2u prime e to the 2x twice. Can be 4u prime e to the 2x. And then plus u double prime e to the 2x. So this is y double prime. And then bring it back into the differential equation and substitute into y double prime. It's a little bit messy. I mean, gonna be long expression and has to collect like many terms at the end. Just be patient. So this is y double prime minus 7 times the y prime, which is 2u e to the 2x plus u prime e to the 2x, and then plus 10 times y, which is, I'm gonna write in the same line here, plus 10 times e to the 2x times u e to the 2x. And this equals 24 e to the x. Okay, e to the x. To make it less complicated, you can see that each one, you have the common factor e to the 2x, e to the 2x. So divide all by e to the 2x. Okay, divide all by e to the 2x. So we have 4u plus 4u prime plus u double prime minus 14u minus 7u prime plus 10u equals 24. When you divide by e to the 2x, now the right hand side becomes e to the negative x, right? Everyone good so far? Yeah? Okay. And next we just collect like terms again and write in the order, the second order first. So u double prime and the 4 and minus 7, that's minus 3u prime. 4u and 10u, that becomes 14u equals 24 e to the negative x. Did I miss anything? You guys tell me before we move on. If we miss anything, it's gonna mess up pretty much the rest of the problem. Okay. So far, so good. I think I missed something. Did I miss something? Let me see.
Yeah,
This is
I think the 14u and the negative 14u cancel out.
negative 14u and that's right. This one, and this one. Yep. Thank you, Josie. All right, looks less complicated now, right? Now we have u double prime minus 3u prime equals 24 e to the negative x. And then we're gonna use another substitution. So we let the new player w b u prime. Now we have two layers of substitution. At this point, w equals u prime. Therefore, the u double prime or u prime is u double prime. Okay. From u double prime minus 3u prime equals 24 e to the negative x. And we make w as u prime, w prime as u double prime. Substitute in here. Now we have the equation w prime minus 3 times w equals 24 e to the negative x. And this is the first order linear differential equation. Okay. And then we solve for w. Same way that what we did in chapter 2. We find the integrating factor mu as e to the integral negative 3 with respect to x, or e to the negative 3x. And then the formula to find the solution of the linear. Some of you use the traditional way, which is very good, very nice. One year I did that way, but students got confused, so I just went back to use the formula. So either way, if you are comfortable with whatever way, go ahead, use the way that you feel good with. Okay, but I'm gonna stick with the formula when we do the problem together here. So w is 1 over mu integral mu times the function f with respect to x, and then this time we're gonna add c. Okay. In the notes I kept using like c1 and so forth, so how about I just use like C1 star, whatever it is, C1 star. I try not to confuse, because one of the students like contacted me like, why C1 in front of C2, C2 in front of C1, and so confused. So basically just the concept of integration that comes along the way. All right, for this case, we have P as the negative 3. The f of x is 24 e to the negative x. And the mu we have e to the negative 3x. So 1 over e to the negative 3x integral e to the negative 3x. The f of x is 24 e to the negative x with respect to x. And then plus c1 star. And simplify in here, we get 24 e to the negative 4x. That's nice. We don't need to use like another technique, just the basically just the use up. Okay, e to the negative 3x here. The antiderivative of e to the negative 4x is e to the negative 4x divided by negative 4 and multiplied by the coefficient 24. Okay, plus the c1 star. Clean up the numbers. We have negative 6, right? We have negative 6. Negative 6 e to the negative 3x, this is the same as e to the 3x. You multiply to all terms. The first term becomes negative 6 times e to the negative x plus c1 star times e to the 3x. And again, what is w? W is u prime, u prime, u prime. At this point, we get out of the layer of w. We are at the u prime, or the u. We are getting close to the point that we are looking for. Okay. So next, since the u prime equals negative 6 e to the x, negative x plus c1 star times e to the 3x. What is the u? We have to find out one more layer by finding the antiderivative. And the right hand side is just the x term. You just do the way that what you did in Calc 2. Nothing fancy, no separable, no other technique other than what you learned before you came to the class. So the integral of negative 6 e to the negative x plus c1 star e to the 3x with respect to x. And that will give us 6 e to the negative x for the first antiderivative, and then plus the c1 star e to the 3x divided by 3. Okay, and then plus another constant of integration. I'm going to put the c2 star. Okay, c2 star. And this is the u. And what is the u? U is the function that multiply to, so we call it y, or the solution y is the u multiplied by y1, right? Multiplied by y1. And what is our y1? Y1 provided as e to the power negative, e to the power 2x, or u times e to the 2x. So now we're gonna back to the solution y, right? Which is a general solution that we are looking for, and then identify what the rest of the solutions, or the solution number 2 and the particular solution. So what I did, so I'm not going to divide, too much work. So I'm gonna multiply the whole thing by e to the 2x to form the y. Okay, multiply each term by e to the 2x. So then e to the 2x times u, that's my y, or the general solution. The general solution of this non-homogeneous equation equals 6e to the negative x times e to the 2x becomes 6e to the x power, okay? And then plus the next one, which is c1 star divided by 3e to the 5x plus c2 star e to the 2x. We have the solution, the general solution, as some term, no unknown, like I call it C1 star and C2 star as the parameters that will give you the family of solutions. The one that contains the parameter, which is from the each time of integration. So those two, they are the complementary solution, which is from C1 y1 plus C2 y2. And the one that no parameter, that's your yp, or the particular solution. Okay, and now what is provided? Y1 is e to the 2x. Which one that contains e to the 2x? That is your y1. Okay, that's your y1. So then if y1 is given, we are looking for y2. Therefore, that is your y2. And that's your yp. So to wrap up, the given solution, the given first solution, y1 equals e to the 2x. So the second solution, y2 equals e to the 5x. See, we ignore the coefficient, but the coefficient will tell you what type of that solution. And then the particular solution, yp is 6e to the x. The term that is clean, no C1 star, C2 star. So that clean term is the particular solution.